Hey y'all, we're on lesson 41 today in our algebra book. This one has two parts. The first part is on the addition of like terms and rational expressions, which sounds really bad, but it's not too bad. We'll talk about it. We also have another part where we're doing two-step problems, two-step equations. Those are pretty simple. We've done equations before. We're going to start off with very simple ones of these. Basically, the two-step equation, you just work out the first part, solve for the variable, and then you use that to answer the second part. We'll look at a couple examples of each, and we'll go from there. Here's the first part of our lesson today. It's the addition of like terms and rational expressions. Like I said, that's a scary sounding thing, but we've done lots of problems where we're just adding like terms. When we look at these here on the board, we've got three different terms. Each one of those terms kind of looks different. It's kind of hard to tell though, and that's because they're all in different forms. You'll notice some of them are fractions, some of them are whole numbers, some of them have positive exponents, some of them have negative exponents. So in order for us to add or subtract them, the only way we can do that is if they are like terms. So that's what we need to do first, is figure out if they are like terms or not. And if we're not given any specific instructions on how to give our answer, I would say just rearrange each term in the way that you're most comfortable with. The way I do it is I just make everything a positive exponent. I like that. It's nice and neat. If you want to do it a different way, that's fine. You can move everything to the numerator. You can move everything to the denominator. It doesn't matter. I just make all the exponents positive. To me, that's the simplest way to do it. And so that's what I'm going to do here. On our first term, I've got some positive exponents, I have some negative ones, and I have some variables that need to be combined. And so that's what I'm going to do. I'm going to leave b at the top because it is a positive exponent. It's 1, even though we don't write that. I'm also going to move y negative squared up to the top. And anytime we move it like that, it simply becomes y to the positive second. On the bottom, I'm going to leave x to the third, but I'm going to move x to the first down there with it. When we move x down, it becomes x to the negative first. So we have x to the third, x to the negative first. Together, that is x squared. And now I have a much easier to read term. It looks much nicer. And I like the way that is. So we'll go to the next one. I've got a minus sign. I've got 3 by squared. All of that is good. I'm going to leave it just like it is. The only thing I'm going to change is I'm going to move x to the bottom. When I move it down to the bottom, it becomes x squared. Then I've got plus this last term. Most of the things are good. All I want to change is I want to move b to the top. So that'll give me 4. I'm moving b to the top now, so it becomes the positive first, y squared over x squared. And now if you'll notice, when we look at the three terms, they are all alike. They all have b to the first power, they all have y squared, and they all have x squared. That means they are like terms. And since they are alike, we can add them, we can subtract them. So we're going to do that like we normally would. Basically, all we do is add and subtract the coefficients. We do nothing at all to the variables. They'll stay exactly the same in our answer. So we're going to have, even though we didn't write a coefficient, it is 1. So we're going to do 1 minus 3. That's going to give us negative 2. And then we're going to do negative 2 plus 4. And that's going to give us positive 2. And like I said, our variables will remain exactly the same. And we'll get our answer, 2by squared over x squared. Let's look at another one. All right, for the second example, I'm going to work it out just a little bit differently. I said for me the easiest way is to make all the exponents positive. Not everybody thinks that way though, I understand that. So maybe for you it's easier to put everything in the numerator, just to make everything one whole number, not to have any fractions or anything like that. So for the second one, that's what I'm going to do. We're just going to move everything to the top, everything into the numerator. So this first term, I've already got a by itself up top. It's going to stay the same, a to the negative third. What I'm going to do is move b to the negative third up here. Remember, when we move it, it changes signs on the exponent, so it becomes b to the positive third. That means I have b times b to the third, so I actually have b to the fourth. Then I have a plus sign. I'm going to do the same thing over here. I have 2, and I have b to the fourth already in the numerator. I'm going to move a to the third up there with it, and when I move it to the top, it becomes a to the negative third. So once again, when you look, we now have like terms. You can tell they both have a to the negative third power, and they both have b to the fourth power. And then we just add our coefficients once again. 1 plus 2 is going to give us 3 a to the negative third b to the fourth power. Now, if I had worked it out the way that I like, I would have had 2 fractions, and when I got my answer, I would have had 3b to the fourth over a to the third. It doesn't matter though, both of those answers mean the exact same thing, it's just 2 different ways of writing the same thing. So do the way that you're comfortable with. Sometimes in the instructions, it'll say, write your answer with all exponents positive, or write your answer with all the variables in the numerator. If it says to do that, you should. If it doesn't give specific instructions, do it the way you're comfortable. First example on a 2-step problem, we have if x plus 3 equals 7, what is the value of x minus 8? Now the first part is very simple. It's a simple algebraic equation. We're going to solve it like we always would. X plus 3 equals 7. To solve that, we would simply subtract 3 from both sides. And when we subtract 3 over here, it goes away. When we subtract 3 over here, we get 4. So x equals 4. If that is true, then we go to the second part of our equation. What is the value of x minus 8? Well, if x equals 4, then the value of x minus 8 is 4 minus 8. 4 minus 8 would be negative 4. So 2-step problem, there's nothing to it. You just find out what the variable is, and then you use that to find the value of the second part. It's done the same way. If x minus 5 equals 7, what is the value of x plus 4? Well, we just look at our original equation here. X minus 5 equals 7. We know that to solve that, we're wanting to get the variable by itself. So to get rid of that minus 5 that's with it, we would add 5 to both sides. When we add 5 here, it goes away, it leaves just x. When we add 5 here, we get 12. So x equals 12. If that is true, then we can figure out that x plus 4 is going to have a value of 12 plus 4. And so it's going to have a value of 16. So once again, there's nothing to this. Just figure out what the variable is. Use that to find the value of the second part.